Recording. Okay, nice. It's recording now. It's not recording now. Yeah. I could remember before I took this exam, what one student who took the exam before us advised me, understand? And which I think is very, very, very necessary that we have to, have it in mind. If you're taking this exam, you have to have the mindset of a researcher. The mindset, a researcher's mindset. That means you are not just answering the questions like a student who just attempting questions. Understand? You are fully immersing yourself, full immersion in the real world of the problem that is presented before you. And you are going to answer it, applying all the principles you have known. That's no need to memorize anything. This is not exam because tell me how much information can you memorize with all the papers and everything we have read. So you have to understand objectively the question that is placed before you and how you can attempt it, reasonably, rationally, based on all the techniques, methodologies, and the principles you have learned in this course. So have the researcher's mind. It's very, very necessary. That's what that guy advised me. And then I think it really works, Not saying yourself as an ordinary student being tested in an exam, but assuming that you are doing the real thing, So whatever you are trying to do, explain in details. The other time someone asked, what's the difference between a master's level question and a doctoral level question? Say a master's level question. Oh, there is a noise at the background. So a master's person might say, for this, in order to answer this question, we are going to use correlation, to tackle the problem. Maybe you are trying to deal with relationship between variables, understand? And then the master's person will say, we're going to use correlation to solve the problem. We have these variables, we have identified it, and then leaves it at correlation. A doctoral student comes and looks at the question, says, there are other multiple approaches that we can use, but the reason why I have considered correlation appropriate for solving this problem is because of so, and so. Understand? Because maybe the variables involved are quantitative numerical variables, understand? And I'm trying to investigate the relationship between these two variables. I'm not interested in causality or trying to understand the mechanisms at work or what structures or mechanisms are responsible for the changes observed in these variables, understand? We are strictly interested in understanding how this one variable, affects the other. So this is a doctoral person talking. He has already explained the reason why he has to choose correlation. Go beyond the surface into the depths, understand? So if you want to be successful in these exams, don't just say anything and leave it. Just like in normal research, whenever you say anything, you have to cite the reference, to avoid plagiarizing. Whatever you say, you have to cite a reference to back up your idea. Understand? So the same thing applies when you are answering questions in the qual exams. You may not need, actually cite references or authors, but for whatever you say the reason for whatever you write. Understand? Indicate why you are saying it. Why you are saying this. If you say you are using case study, why do you choose to use case study? Because someone might ask, why not use ethnography, understand, or action research? So it is not enough to say, I will use case study. We have decided, or I decided to use case study as my approach. So what if I say, can't you use ethnography also? Understand? So in order to avoid that conflicting or contradicting, understanding, or to anticipate questions people might ask you, why not use ethnography instead of, So you already discuss, why you are using, and go in depth in discussing why you decide and why you consider case study, for instance, to be more appropriate. So it's very, very necessary that whatever you say the reason why you decide to take that stand, and always be logical. That's why you need to go back and proofread before you submit, because a single word can just mess up the logic, and you don't expect the professor to figure out what you are trying to say. It is more critical in doctoral qualifying exam than in any other exams Understand? The logic of your argument is very necessary. So that's all about the intro. So the timetable that we are going to begin with philosophy of science in intro, then we are going to proceed with quantitative qualitative design research. So for now, we are beginning with an introduction to IX research, because I think it's very, very necessary. We need to familiarize ourselves with some of the concepts, some of the paradigms, some of the philosophies, that will all embracing, embraces the whole of the research in IX. And IS belongs to the social sciences, understand? And the social sciences are always interested in real world research. We are the one to solve practical problems, but we can also solve a conceptual problem to provide a better understanding of how things are working. Now, so I'm going to stop sharing the screen now. So guys, I want us to touch upon the craft of research. There is something, we are not going to go through the whole book, but there are some important things I need to mention because it's very good for your logic when you are writing an exam of this nature. The paper discusses, the book discusses about claims, about reason, about evidence. But first they discuss about problems, the kind of problems. Wait, I'm gonna share, and then I'm gonna make it bold for you to see very clearly. So, can you see my screen larger now? Yeah, okay, yeah.
Yes.
So why I decided to bring up this thing, because I know that there's a whole lot, all the information on that in that book is very, very necessary. But they discuss about practical problems and conceptual problem. Depends on what kind of problem do you want to solve. Understand? Is it a practical problem? There's a practical problem that you are going to provide a solution to an existing problem. Understand? And practical problems are very difficult. Sometimes it comes with a lot of overheads, like costs. Understand? And it's all about changing how people behave, about an act, introducing something new, maybe kind of artifact. So sometimes people are very resistant to such change. So solving practical problems are really difficult. Most of the things I see are people trying to offer conceptual, solutions to problem in that way you are trying to, clarify a confusion or an understanding, provide a better conceptual framework to understand things, to clarify the kind of fuzzy idea along the line. So they mentioned about practical problems and the conceptual problem. So it depends. When you have a research problem you are interested in investigating, you have to ask whether it is practical. You have to check whether it is practical or conceptual problem. So like in my own now, what I'm trying to work on is like, it's a conceptual problem, understand? But it might have some practical relevance, Sometimes conceptual problems can have practical effects, on practice. Practitioners can borrow your idea and try to work things out for that. So,
sorry, Clement, this what you shared, what is it about? The claim reason? What you're sharing, what is this?
Yeah, that's what I'm coming now, understand?
Okay.
Yeah. So these are what I would call the skeletal framework, of every research you see in IX. Understand? Every research, every research, have a claim, they have reasons, they have evidence, they acknowledge responses, and there are also warrants, And the claims say, what do you want me to believe? We have some examples from this paper, from this book. What do you want me to believe? What's your point? Most times, one thing I observe is, if you want to critique a paper and you want to understand their central claim, sometimes it's not very clear from the paper. I don't know if you guys have observed that. You are reading a paper, you want to understand what's their claim. You can't even figure out what's their claim. Sometimes even discovering the reasons might be very difficult. Understand? Like now I'm doing an annotated bibliography. The professor asked me, for every paper you read, look at the claims, their reason, their evidence. Believe you me, there are some papers I read can't even make sense of what is their central claim. What reasoning are they providing, for their claim, and then what's their, the evidence, But most times from observation, especially when you are doing a quantitative research, most of the claims, come as hypothetical, statements of relationship between one variable, maybe the dependent and independent variable. By that I mean, if you take for instance the UTAUT framework, the UTAUT model. We have performance expectancy, we have effort expectancy, we have social, we have facilitating condition, and the rest, with all their moderating variables. So when an author says, we hypothesize that performance expectancy, understand, we have a significant effect on behavioral intention. That is the claim. But if you want to read the whole paper and say, well, to understand where they mentioned like a claim, you won't find it. You won't find it, stated clearly. But this hypothetical, or the hypothesis of the research could be a kind of claim. You are claiming that performance expectancy or effort expectancy, we have direct effect, understand? And most times these are the research questions. So most quantitative papers, you don't see a clear research question. So most of their research questions are embedded in these hypothetical statements, they make. And these are the claims, because if you look at it, it is really a claim. You are claiming that this will have a significant effect on this. You may have up to, depending on the kind of model, like in the UTAUT, you may have up to 4 to 5 hypothetical statements relating to behavioral intention. And this is your claim. But this book has a kind of, they have another way of saying this, to make it very clearly what example of a claim and example of, okay, look at the claim here now. It's an assertion, it says, climate change is threatening coastal cities. Toni Morrison's The Most Important Novel is Beloved. Your main claim is the assertion your whole research argument supports. Some call this the thesis, understand? That is the claim, understand? And the claim might be, factors, investigating factors responsible for maybe cardiac arrest among the elderly. It is a kind of quantitative type of question, understand? So that initial assertion will be framed as a claim you are making. When you try to hypothesize, for instance, says excess intake of sodium, understand, sodium chloride, that is salt, is responsible, for this. So that is a claim. So it also, your claim can also come as a kind of thesis, overall thesis of the paper. Then you have to provide a reasoning. Why? Why do you say, for instance, that high intake of sodium is responsible for cardiac arrest? You have to provide a reasoning. So the reason it says, because it usually, I'm saying that high intake of sodium is responsible for cardiac arrest because of what? Understand? Maybe because you have seen that, with age, people usually, have cardiac arrest, but that sometimes may not connect with your claim. That's why sometimes you need warrants to buttress your point. So a reason would say, look at the reason for the example we have here. They said, this is a claim, and then the reason is because Morris's major themes find their fullest development, based on climate change threatening coastal cities, So the reasoning they provided is this, because in Beloved, Morrison's major themes find their fullest development. Then the evidence, this is another where there is so much confusion, The evidence is the data you are collecting. The evidence is the data you are collecting. Does it resonate with you? You are collecting data. The data you are collecting is the concrete evidence you are providing. So sometimes the evidence is not framed as a kind of reasoning or claim. It doesn't come, with all the logic. What it requires is the data. It could be demographic data. It could be data from any primary or secondary source. It could be from a peer-reviewed source where you get all the data, understand? And they say maybe so from 2016 to 2019, hospitals have registered an increase of cardiac arrest, and then you provided the raw data, and that is your evidence. And usually what we do in research is you posited a claim, which is your kind of thesis, understand? And then you give a reasoning why you are doing this. Understand? You provide a reasoning why you are doing this. And then you want to convince people, you know, through the hardcore evidence you're going to provide when you collect your data. Understand? And that's why usually we try to look at, say, does the data collected, does the data, you know, collection approach appropriate for the problem being solved? Is the analysis, does the analysis actually throw light or give insight into the problem you said you are solving? It is the evidence, the data is the overall, you know, most important factor. Understand how you collected the data, you know, from the which subjects you collected the data, is it appropriate, and does it analysis, you know, actually, because it is your evidence that is going to provide an answer, you know. So sometimes when you have, that's why we always have problem in a small sample. If you don't have a significant sample, you have problem, understand? So because the sample, the data is the evidence you are trying to provide. So in every research paper, there is always a claim, which may be a kind of a hypothetical statement. We hypothesize. Some will make it very clear, but some will not even, some will just simply say, this is our research hypothesis. Some will frame it as we hypothesize. You know, that is their claim. And their thesis are based, you know, on this central claim. They give you reasoning why they want to investigate this problem. Understand? And also try to provide evidence through the data they are going to collect. If you don't have a substantial amount of data, understand, you know, and the collected data, you know, from reliable sources, you know, maybe from secondary or from primary sources. Usually we go for primary sources because we want to get to the actual people. We collect information from the actual, where the problem is happening, understand, you know, maybe it's through an experiment, collected the experiment, you're collecting the data from the actual people. If you are investigating teachers, then you are going to teachers directly and not on the student. So that is what is very, very important. So the claim you are raising. So whenever you are framing up a research question, understand, or you are answering a question in qual exams, always keep in mind, what's the claim? What's your reasoning? So let your idea flow, you know, through this trial. And it's very, very important. And then we have warrants, you know. I may not read up what we have here, understand, we can look up for it in the textbook. But to give you a simple example, maybe someone says, we had gunshots. Maybe, so, okay, let me just a practical example, like someone makes a claim, you know, saying, maybe armed robbers, you know, robbed on the street last night. Why reasoning? Somebody asks why reasoning. Say because we had gunshots. But do you have any evidence? Understand? Maybe say our next door neighbor was actually arrested. That's one of the evidence. But someone will say, how does gunshots, understand, connect with maybe with robbery on the street? It could be something else and not other than robbery. It could be someone just released the bullet. Understand? And one of the kind of warrants people usually say is because there is no smoke without fire. It's example, you know, every discipline have their own warrants just to connect the claim and the ideas. Okay, there was a gunshot, and then you made a claim that the police, there was an arrest on the street because there is a gunshot, and they want to buttress you are reasoning further. You say, hey, there is no smoke without fire. You know, yes, you know, that's a kind of warrant. There are many other warrants, and these warrants are like technical languages that people use in different disciplines. Understand? You know, no smoke without fire. Yes, there was gunshot, really, and then there was an arrest. Your next door neighbor was arrested. So you always anticipate, acknowledge that people are going to ask you questions, you know, and that's why, to avoid creating that loophole for people to ask you questions, because people must surely ask you, how does the reasoning connect with your claim, or how does your evidence actually, you know, answer the question, you know, that you claim to solve. So you have to anticipate that people are going to ask you questions, and then you acknowledge ahead of time what possible responses that people could ask you, So how does, like the person asked, how does gunshots connect with arrest? Understand? With arresting, connect with your armed robbery. Understand? What if it is some other thing that is not armed robbery? You said the evidence is your neighbor was arrested. What if your neighbor was arrested for some other thing, a car theft, and nothing else? So sometimes we leave loopholes. So look at what's your logic when you are writing, understanding the qual, and in research in general, because what we are saying here applies to all quantitative and qualitative research. You look at your argument, don't leave any loopholes for people to begin to discover the reason doesn't connect with the claim, and the reason is not cogent enough to support the claim. Understand? Then your evidence also must be from primary sources, collected using the appropriate methodologies. So that's why I wanted us to look into this. I think everyone is very clear about claims and reasoning and evidence. So the claims may not come clear in the papers you are reading. So, but there are always hypothetical statements that could be made in quantitative papers. In qualitative papers, sometimes they can state it very clearly. Look at what they are claiming. But if you want to discover their claim easily, you can look at what the problem that they are going to solve. What problem did they set out to solve? From that problem, you can actually make up, or even from the research question, you can be able to make out, what they are claiming, because sometimes it doesn't come very clear from the papers we read, So our evidence is the data we are collecting to convince people that this effect really exists. Understand? This effect really exists, or it doesn't exist. Sometimes it could be a two-third hypothesis, whereby it could be either this or that, So that's all about claim and reasoning. And then we move into, I said today, after we are done with this, we are going to move into Benzabat and Smooth. So we have to bear this in mind. Always make your claim and then your reasoning and then provide evidence. You can support your claim and reasoning with a warrant, understand? That makes it more cogent, and then that makes you close any loopholes, for people who might ask you question, why is this so and why is this not so? I will stop sharing from this, and then, guys, we are going to look at something very interesting, Benzabat and Smooth, pioneered the argument about the boundaries of IS research. You and I know that when it comes to age of the field, IS is just relatively recent, and it's a kind of it has a kind of multidisciplinary background. Business guys are there, management guys are there, computer scientists are there. For some of us who don't have that IT background, understand, we are struggling to understand what is happening, for business and management people, engineering people, from where IS, was given birth to, So that's really a problem, because Benzabat and Smooth are trying to say, we have to have our boundaries, understand? We have to have our boundaries, and they try to discuss where this boundary, should be responsible, what are the most important factors that we are to look out for when we are looking at boundaries in IS research, because they're very clear. Yes?
I was just going to say, I think this paper seems like a really good one to reference on the qualifying exam, because it kind of identifies what is and what isn't IS. And you can use that to criticize or complement, I guess, papers that you're reviewing.
The papers, hello, can I get you clearly?
Did you hear me okay?
Yeah, can you come again?
So I was just saying that I think the Benzabat and Smooth paper seems like a good one to just have in mind for the qualifying exam, because of the fact that it tries to define IS, and they always give you a couple of papers to look at. And so if those papers stray from the definition of IS, then you can bring that up when you talk about how they researched it.
Okay, you can share any papers you find relevant, just share it. Maybe you can drop it in the WhatsApp group. Then I can upload it in the folder. So I want to ask you guys, what do you think about, Benzabatan's mood paper about the errors of inclusion and the errors of exclusion? Because IS is a multidisciplinary, field. It is very important to actually delineate, understand, or define what the boundaries of the kind of papers, that populates, this fields, central, research. Where should our focus lie? What makes us different from other fields? Understand? So the kind of it's a struggle for differentiation, because if this differentiation doesn't occur, then IX might lose its identity. It might become another engineering, another management field, or another computer science subject. Understand? So that's really, really a very important issue there. So they say we argue that the primary way in which a scholarly discipline signals its boundaries, and in doing so, its intellectual core is through the topics that populate this discipline specific research activities, so research activities. So they came up with the errors of inclusion and the errors of exclusion. And these errors are all about the error of, inclusion. For us to understand the errors of inclusion and the errors of exclusion, it's very necessary we look at the IT artifact. Look at the IT artifact. The IX as a multidisciplinary course, our focus is to study technology and the human presence and the interaction, human-computer interaction, and also the phenomenon that emerges as human beings interact with computers. And a computer is an example of an artifact, something that doesn't exist, of nature, like Simon. I've forgotten the name of Simon, the man that wrote the seminar paper on trying to describe the science of artificial. Understand? Artifact is something that is man-made, something that is created to solve a certain problem. Understand? So computers could be an example of that, and many other things. So in IX research, our interest is to study humans and their interaction, to predict what could be the outcome of the relationship between human presence and the computers. And because of this, we also need computer scientists. We also need behavioral psychologists. Most of the IS theories, understand, have a lot of psychological background, because you're trying to predict. If you look at the youth out, or look at the time and the time model. Remember, like I mentioned the other time we met, the time model is already outdated. So please don't cite it for any reason. The time model is already outdated, and I will give you a reason why it is so. I wrote a paper with Professor Chinazunwa. We submitted the paper to European Journal of Information Systems. They rejected the paper. And among the comments made by the reviewers is that the term is an outdated model. And then I asked the same question to Professor Ryan. Why did this reviewer, made that kind of remark? Why did he make that kind of remark? Understand? Professor Ryan said, if I were him, I would say the same thing. I was kind of shocked. So my reason is, why do we emphasize so much time teaching time in high school when it is no longer relevant? Understand? But anyway, why we need to still have that kind of background in time, because whatever we are discussing today, youth out has more than 65% of predictive validity. It has stronger validity more than time. And if you look at some of the constructs in youth out, which is the central model in IX. Understand? The only kind of theory, even though some people will say it is not a theory, the only thing we can be proud of when it comes to predicting human relationships and human interaction, with technology, human adoption of technology, and all the phenomenon that goes with it. Understand? When you look at it, some of the constructs are based on from either perceive ease of use and perceive usefulness, understand, which are, constructs in term, they're all embedded in UTOUT, understand. And then socio-cognitive theory, and there are so many other theories, theory of planned action, So they're all there. So UTOUT is the most comprehensive, because before Davis and the rest came to the before they arrived at the constructs that actually informed the UTOUT theory, they already looked at all these theories, understand, and then made a decision of what should be there and what shouldn't be there, understand. So now we are studying, a course in information systems, and our goal is to add value, they will say, add value to, the use, how people, interact with computers, with IT artifacts. And there is no other field that will tell you, that predicts well how humans use computers, than the IX field. And that's why this field is here, understand? Because we have seen instances where technology, was implemented to solve an organizational problem. And it's either it gets worse or nothing was actually achieved, because either they made the wrong decision or the kind of technology, understand, or the timing of introduction wasn't appropriate, understand, or some other factors that our scholars would have studied to understand whether this IT artifact actually solves the problem on ground, So at the center of it all is an IT artifact. It could be a software, understand? It could be a computer system. It could be a human resource management system. It could be anything, but there is always an IT artifact, something designed, man-made, understand, to solve a problem. We can use computer as the most simplest example, understand, how introducing maybe a workforce that is transiting from manual checkout system to computerized checkout system, understand, the introduction of a computer. Sometimes this involves the changes in organizational behavior. So we also want to study what are the changes in behavior, understand. We want to understand how the changes in behavior, to understand better, how the introduction of the IT artifact or the computer system, maybe improves, the overall functioning of the organization. And then you will look at, apart from human beings and the IT artifact and computers, for instance, we also have an organization. It's all about improving, organizational relationship with the computers, how human beings interact. It's always within an organization. There is always a context of our research, understand. UTOUT was first validated within an organizational setup. I hope you know the UTOUT 1. Then the second UTOUT, UTOUT 2, was validated within a commercial setup. So they took it from, the organization where this theory was first tested, and all the instruments, validated within that organizational setup. Then, in order to test it in a commercial setup, they discovered that, there are some other variables that needs to be added, that are very significant when you are handling in a commercial setup. And it was like in Hong Kong, they tried to investigate, mobile users in Hong Kong. The first was within an organization. The second UTOUT was within, in a commercial, trying to investigate mobile users in Hong Kong. And that was then when they discovered that hedonic motivation plays an important role, habit plays an important role, price value plays an important role. This trial wasn't there in UTOUT 1. Understand? The hedonic motivation, the price value, and then habit. Because price is very important. In organization, people are provided with computers. You are provided with all you need to work. But when it comes to a commercial setup, you have to procure the computer, the phone or the computer yourself. So the game changes. So price value becomes an important, significant predictor, in the whole model. So that's how I'm emphasizing organization, the context, the people, working in the organization, and then the IT artifact, which is at the center. So an IS scholar is either studying the IT artifact, maybe the computer system itself, or the usage of this system, or possibly the impact of the system, you know, on the organization. And this impact could affect the IT managerial, the methodological, and the operational practices, because it always, all the time, involves some kind of adjustment in the way the organization, you know, performs prior to the introduction of the IT artifact. You know, so it has these implications. And then the impact also goes to IT managerial, methodological, and the technical capabilities. So you see that all these lines, you know, showing there is a kind of relationship. So it might be if you are an IS scholar, there will always be an IT artifact you are studying. And if you are studying some other thing, like for instance, look at the example of the error of exclusion. Look at the example of error of exclusion. What do you think is the problem here? The dependent variable. I'm looking at the dependent variable here and the independent variables. From this model, you can decipher that the dependent variable here is client satisfaction. Looking at the arrows, it's very important to look at the arrows. When you do PLSM, you understand the importance of these arrows. Or when you are creating a model, the movement of the arrows are very, very important. You can see like a moderating variable. Outcome clarity that moderates the relationship between task dependency and the client satisfaction. You can also see that it's also a relationship between task dependency and the mutual understanding. And all these other variables predicts, understand, client satisfaction.
The client is a dependent variable.
What?
The task is independent. And as you said, the outcome is a moderate variable. And also the member mutual understanding, it could be, it comes as dependent and also independent.
Yes. So what are you trying to say in earnest?
So basically the task interdependency is an independent variable.
Yes.
And that is like another word is I think the predict variable.
Yes, the predictor variable. Yes, from the movement of the arrow, understand, you already see, you know, the relationship. And then if you read the explanation to this model, understand, you know, that's to tell you that task interdependency, you know, kind of predicts, you know, client satisfaction. But now they see the problem of error here is that and there's no IT artifact. No, there is an IT artifact, but this study does not focus on the IT artifact. It could be, this model could be in the context of studying maybe maybe the introduction of a computerized system, or say a human resource software that organizes how work is done in the in the organization. There may be an IT artifact, but the goal of this study is not the IT artifact. They are studying client satisfaction. And client satisfaction in the use of the IT artifact. Understand? So an IS researcher might be conducting a research within an organization, understand, where there is the IT artifact already, you know, or you might be studying the impact of the IT. You might be studying the IT artifact from the perspective of the behavioral sciences. Like that's what is happening here. Client satisfaction. That should be left for maybe behavioral scientists to figure out. I'm not for, you know, IS scholars. And then the error of exclusion also comes when it comes to the kind of theories we use. Understand? Like you're looking at the youth-out model. Can I quickly get the youth-out model?
Sorry, back to this error of exclusion. I'm a bit confused. What exactly is the error here?
Okay, that's what I'm saying. the error is that from when you look at this, the IT artifact and its immediate nomological net, because the whole argument of Ben-Besant mode is that everything should be around the IT artifact and its immediate nomological net. They are trying to draw a boundary. It mustn't go beyond the IT artifact. And all these other nomological net, the usage, the implication, IT managerial and IT and the methodological and the technical capabilities. Understand? So it's either you are studying the IT artifacts from the perspective of its usage or its impact. Understand? In that case, the IT artifact is there, but the primary goal of the study or what you are trying to predict, understand, is the impact of the IT artifact on the organization. But here, the error here is that this model or this study is studying client satisfaction. And this client satisfaction has nothing to do with the impact. So the goal of this study is to predict, understand, the client satisfaction and not the IT, impact on client satisfaction. Understand? They give another example. If you read this paper, with an e-commerce website, sometimes in an e-commerce website, somebody say the IT artifact is e-commerce. Understand? But what should be the interest of an IS scholar in e-commerce? Is it to study the e-commerce as an ecosystem or whatever, or as a web platform? So sometimes they give an example here in this paper that our interest might be on how to improve, the visualization of products. Understand how we can use technological capabilities, maybe a 3D platform to improve, the customer's appreciation of most of these products that is being displayed on the e-commerce website. Understand? So the exclusion here is that you are not studying the IT. Yeah, America, I saw your hands up. Like what I'm currently battling in my own dissertation now is I am doing a course that is more related to the educational field. Understand? If I don't have an IT artifact I'm studying, you would say that this should be better left for educational people in the educational field. Understand? There is something you'll be doing, and it is better left for those who are doing management sciences, or those who are doing business studies, or those who are doing engineering per se. Understand? So what you are doing when it comes to theory, for instance, too, with regard to the errors of exclusion, you exclude all the variables that should predict. For instance, you are using the UTAUT model. Understand? And instead of using the whole variables in the UTAUT model, you exclude some of them. Understand? Or you bring in more variable from other behavioral sciences, such that the number of variables, understand, you are bringing in excludes the most important variables in IX. Amrika, we want to ask a question.
No, I was just gonna say,
yeah,
I could kind of try to explain like how I understand this mud paper.
Yeah,
error exclusion, just to have a different perspective. So from what I understand, the mud paper, it said that like the IT borderline needs to lie within the numerological network, which needs to focus on somewhere on the IT artifact. Yes. And in this ream right here that you have on the screen. And what they discovered was that there's areas of exclusion, meaning that papers that are included in the IT publication, a lot of them should have not been included. So there's an area of exclusion. They should have excluded those, but they didn't.
Why?
Because they did not focus on IT artifact or this numerological network. Exactly. It was something different, like you're saying.
Exactly.
That should be left to something else.
Uh-huh.
Yeah.
Yeah, exactly. You're on point. Understand? So they are studying some other thing that should be better left for maybe like the people who are doing education. Understand? So we have to look at the IT artifacts. The IT artifact should be at the center. So sometimes the IT artifact could be you are studying the impact of the software, impact of human resource system, the impact of maybe a new software or a new system introduced in the, so when you are writing the IX paper, there must be, like in my education paper now, I can decide to say learning management system. Understand? I'm going to investigate maybe the impact of learning management system on the curriculum development of flexible learning, and there has to be something that has to do with the IT artifact. Otherwise, if you want to study student satisfaction on the courses they take, understand, in an e-learning class, e-learning doesn't make it IT artifact. Understand? You know, so that you are studying the performance of student or student satisfaction in an e-learning class. There, for the fact that some will argue, oh, because it is e-learning, it is computer-mediated learning, and therefore the computer-mediated learning makes it an IT artifact. No. Remember, what you are studying is student satisfaction. You are not studying about the technologies involved. But if you are interested in the technologies and how the technology impacts student performance, you are doing IX. If you are not doing that, then you are excluding something, the IT artifact. And even, it could be the IT artifact, or it could be any of these variables in the East nomological net. I hope this is very clear. Understand? So always have a system in mind when you are doing IS, you know. So the errors of inclusion, even when the IT artifact or other elements associated with its immediate nomological nets are included in such research model. The significant causes is, involve the examination of constructs better left for scholars in other disciplines. Constructs. Now, this error of inclusion is talking about constructs. That's why I give an example of using the youth out, for instance, you know, because you have to take this paper beyond the IT artifact to think about theories in IX.
Clement.
Yes.
I got a question for you. Can you give more details about the artifact? Like the artifact itself, like for example, I know it's most widely used in software.
The IT artifact.
Yeah, so it's like a model.
The IT artifact? No, the IT artifact is any man-made. If you read Simon, I've forgotten the last name, understand? Science of the Artificial. He defined what an artifact is. Something created by man, something that doesn't exist of nature. We use an example of like a computer, your iPad, it could be your MacBook, it could be a human resource management system, it could be like a kind of software, something designed, you know, by man to solve a problem, understand, which have an impact in the way an organization functions. So that's an IT artifact. Something created, something that has technological capabilities, understand? Not just anything designed by man, understand, but something that have technological capabilities, something that can, its usage can impact in an organization, something that can influence and change how things are done, created with, you know, by man, you know, that has technological capabilities, understand?
So it's like a model that involves technology.
Yes.
Okay, gotcha.
Yeah, IT artifact we are talking about this has to do with technology. It cannot be any other thing apart from something that have technological capabilities. Understand? So
okay. Yeah, because I always like know about it comes with the software. Like the
yes, the software can be an IT artifact.
Yeah.
Sure. The software can be in design science research. We try to design, we try to create this IT artifact to solve a problem. In the rest of the IX, we study the impacts of this artifact and people, and, you know, in the context of the organization. That's where you can also distinguish between design science research and the rest of the IX. They say that the rest, that design science research continues with, you know, whatever that is left behind, you know, of the rest of the IX, such as softwares, hardwares, and other processes. IX as a field deals with the humans and the IT artifacts, understand? And then studied behaviors that surrounds this, and the interaction with human-computer interaction, and the phenomenon that emerges. And this phenomenon that emerges can also be used to predict future usage of such systems, or modify the use of such systems. Understand? That's what IX does. So in design science, which is an approach to doing IX, not a research methodology. Understand? I want to clarify these things because from my own experience, students get confused most times. Understand? So design science comes in to handle other things that are left behind by IS scholars, hardwares, softwares, processes, and the rest. Understand? So we want to design the actual software. An IS scholar can simply investigate the impact of an already made software introduced in an organization. A software that is already implemented, a hardware that is a computer system that has already been implemented in an organization. That's what you are studying. The design scientist is interested in solving a new problem that emerges within that organization in a more effective and efficient way. Understand? So that's where we come in. We want to solve the actual problem, and there is a context for solving that problem, and the goal is to, show that we can design something that is, if it is an existing problem, maybe there is already an artifact in that organization, but it doesn't do the work very well. A design scientist comes in to say, we can design an artifact, that can solve this problem in a more effective and efficient way. Understand? If it's already an existing problem, or if it's like a completely new problem, what we call wicked problem, those kind of problem that requires, so much creativity, intuition, we can figure out how we can solve this problem by creating an artifact. Understand? So you are more interested in designing something, producing the artifact yourself. Why the IS scholar is interested in studying this IT artifact. And for it to be IX, the IT artifact, and all this in its immediate nomological net should be there. Now, talking about the error of exclusion, now we are using this model as an example. Understand, this is the UTAUT model, the UTAUT1 model. Understand, this is the core IX theory or IX model. If you are working with this model, understand, you are going to work with all the variables: the performance expectancy, effort expectancy, social influence, facilitating condition. And then all these at the left side are the independent variables. They are the independent variables, understand, predicting behavioral intention. And all this line says there is a significant relationship, to behavioral intention and facilitating condition directly to usage. Now, an error of exclusion comes when you bring in, let's say, from another behavioral science, you include 4 more constructs or 5 more constructs, removing social influence, or you remove performance expectancy, remove effort expectancy, and add additional 5 constructs from behavioral sciences. You are excluding what should be the core, understand, of our IS theory. Why are you removing? Understand, because you have to provide a justification why you are dropping a variable from a model. Usually we advise not to do so. So if you include, or you are if it may not be the UTAUT, understand, maybe you come up with a new model, maybe based on the UTAUT, and they discover that most of the constructs in that model are not from IX or anything related to IX. Understand, you are including so much. Understand, you are excluding the core IT constructs and then including what should not be there. That is, you are borrowing so much, over borrowing. That's the way the Benzema will put it, you are borrowing so much from outside and then leaving up what should be ours. Understand? Though we don't have any kernel theories or ground theories, understand? But the U-Tout works well for us when it comes to, prediction of human usage of technology, adoption of technology. The U-Tout is always there. And most of the theories you will see in IS is a kind of different modifications of the U-Tout, including more variables from other to predict, to see if they can have a predictive effect on behavioral intention, understand? So whatever theory you are going to use, ensure that the constructs have relationship with the IX, understand? So if you decide to use maybe what kind of theory would I use? Maybe human capital theory. Human capital theory is a kind of still have some relationship with IX. There are some constructs in the human capital theory. The more people get education, the more their the money, their earnings increase. Understand? You have to investigate those constructs and see if there is any construct that is related to IX that might be borrowed and then added to this model. So what you see most researchers doing is either adding some other construct into this model, but this construct has to be well operationalized, understand? Pilot tested, validated for reliability, understand? Before they will be included in the construct. So if you are coming up with a theory you want to study, because there is always emphasis, they say theory is king. We are going to touch upon theory. We're not talking about theories today. So if you're going to use a theory, ensure that your theory doesn't include so much of a constructs from other fields. Understand? If you include so much construct from psychology, then you better do a psychological study and not an IX study. Understand? So that's also what Ben-Zabat and Zumut said. But there is a lot of responses. What's your own take? Let me tell you what's my take here. We don't need to have a rigid boundary because of the multidisciplinary nature. Agarwal, there is another paper that is a follow-up. There is another paper that is a follow-up to Ben-Zabat and Zumut. You guys remember that paper? Yeah, okay. Yeah, let me check quickly. There is another paper that I agree in total with what those guys, trying to open my Google Drive and see where I have.
So Clement, while you do that, the U-Top model you were showing,
yeah,
it seems like the only IT artifact in that is the dependent variable, right? At the end, the
behavioral. No, the dependent variable is the behavioral intention, which is not even. It is more of cognitive, more of behavioral sciences. Understand? Human intention is not like IT stuff.
Yeah, and all the stuff on the left is
Independent
psychology,
variable.
and all the stuff on the bottom is psychology, and behavioral intention is psychology. The IT artifact in U-Tout is the usage of the IT, whatever
exactly.
IT you're doing.
Exactly. But this construct have already been validated for use in IX. Understand? So we make it becomes our own. They have been validated. So if you are going to bring in, like most scholars we do, they include also other constructs from other disciplines. Ensure that you don't include constructs that undermine the reputation of the models we have. Otherwise, that will be our dropping off these ones that has already been validated within this field. Understand? So almost like once it comes to predict, you can't, anything that has to do with prediction, understand, of human usage of computer, no matter what, the U-Tout always comes in. Sometimes you see some scholars dropping the moderating variables in U-Tout. That could be understandable if you have to give a solid reasoning why you think it is not appropriate to include those moderating variables. Understand? And
is the paper you're doing about U-Tout, are you trying to find another moderating or mediating variable, or are you just talking about the acceptance of some learning thing and you're using U-Tout to show how people will accept it?
Yeah, where you are doing the prediction.
I mean, your paper, I'm asking about your particular work that you've been doing that was using, you said you were using TAM and you should have been using U-Tout.
Okay, yeah, the paper they rejected, with ages, yeah. We used the term actually, understand? When we wrote that paper, I'm not so much informed, when I read the paper. Had it been now, I would have given a better critique. I know I wouldn't have used term again because U-Tout have a stronger predictive validity, understand? So term is just like, it doesn't account for anything, because what we are looking at today, the explain the variance, understand? You know, explain the variance. And when it comes to the explained and unexplained variance in a model, UTAUT accounts for more explained than the unexplained. I don't know if it makes sense. Understand? You're looking at the percentage of prediction, UTAUT goes as much as 60 something of what is explained. And it is what is explained is what you can actually use, you know, to predict. So the unexplained variance is lower. Understand? That is what you are not, what you are uncertain about it, because no model can give you 100% predictive validity. No model. But if you have a model that accounts for, you know, most of the explained variance, you have a good model. Understand? That accounts for up to 60 or 70% of what was explained. You have a good model. Understand? And so UTAUT, you know, accounts for more than TAM. You know, so why would you use TAM when you know you have a model that can give you a higher percentage of accuracy?
So in your case, your IT artifact in the nomological net was the usage of learning software? Was that what it was?
Yeah, it was learning. We are doing like an e-learning. The paper was on e-learning, you know, e-learning in Nigeria, understand? We use the term, you know, and then another problem they complained, you know, was the poor sample. They said that the sample is very poor because I was able to interview only 10 students in Nigeria. Man, it is very, I vowed never to do qualitative research in my dissertation.
Like how
10,
many samples you want? How many
10 students. I interviewed 10 students in Nigeria from here via telephone. For each conversation with the interview, it's about 5 minutes. I have huge data of transcript for just 10. Imagine if you have to analyze 100 people. Oh my God.
How many is the
40, 50, even 100 pages of transcript to transcribe. Yeah, so I said, no, I prefer quantitative. Deal with numbers, man. You know, do the calculation, run the software, and then plug in into SPSS and then run your analysis as fast as you can and get your data done. You know, but you know, mastering the software is like SPSS or mastering the PLSM could be very difficult. But I better challenge myself to learn it than to, you know, worry myself with a huge, massive amount of data. And most times when they are talking, most of these people you are interacting, even here in the US, I observed that. America, I saw your hand up. I saw your hands up. So even when you are interacting, that's from my research. It's another research we did in class when we did the qualitative research. When you are interviewing people, I have used the Zoom audio, you know, to do interview in this country. And then I use the author.ai to transcribe the data. Man, messy data. Because what people actually say, understand, is different from what the software is transcribing. And I got this transcription free of charge because that was the first time I'm using the software. So I still have about 600 or more words to transcribe free of charge because the transcription comes with a cost, understand? And the author.ai is integrated with Zoom, understand? But the time we conducted the research, it has not been integrated the way we have it now because it was a later improvement on Zoom, understand? So people like, I interviewed one Black American, you know, say, hey man, you know, so you got it, you got it. At the end, I couldn't even read. If not that I recorded it, also I can listen to the audio and make sense of it. The transcribed words means nothing. Understand? That's another challenge you have when you are doing interviews, especially when you are recording. If you want to transcribe, you won't understand the transcription software and what's all the messy data that comes up there. Not readable. Most of them are not readable because the words didn't come out, you know, the way it was pronounced. Understand? So imagine interviewing like 50 people or 100 people and you have to, you know, get yourself engaged with this kind of thing. Let me listen to Amrik. So I'm still searching for the paper Agawa.
Oh, no problem. So what I was going to say, I think I could be wrong, but I think what Patrick was saying earlier was why UTAUT is an IT artifact. And he was saying that it's because there's a certain part of it that's because from what I understand, the reason UTAUT is an IT artifact because it produces the result.
UTAUT is a model. It's a model in IT, not an IT artifact.
Right, but if you were gonna write, if they were gonna ask you, hey, here is UTaught, can this be included according to Zmud? It would be included because it's producing something that allows technology usage. Like, what are the chances that people are going to use technology, right? So
Yeah, because it's been validated already.
Right.
It's been validated for our use here, so it becomes an IX model, or call it one of the most valuable theories.
Model. But
yeah, because it has validated, it's been validated, so it becomes like an IT model. You know, the one we can boast of as coming from us. Because the rest of the kernel theories we have actually are from behavioral sciences. Right. And we borrow a lot from them, understand? Even the IT artifacts, all the variables you see in that model, you see, they are mostly from behavioral sciences, psychology, and the rest, understand? But we appropriated them and, you know, conceptualize them differently, because that's usually how you start building a theory.
But I don't think it was a mistake that UTaught has been used. I don't think it's an error of what would be an error of inclusion, where you're including something that a paper that doesn't involve IT artifacts. I think UTaught does involve an IT artifact, and it's the thing being used at the end, the last box on the far right of the model.
Yeah, the usage of technology.
That's the IT artifact, right? Does that count?
The usage of the IT artifact, which means what you are actually predicting is the behavioral intention to use IT artifacts, and not intention for any other thing. So that usage there means a lot in that model. Understand? The intention to use the IT artifact, it could be the intention to use the computer, it could be the intention to use the software intention. So you are predicting. That's why the behavioral intention also has its own conceptualization. Understand? There is a kind of definition they give to it if you read that model very well. So that definition aligns more with IX than the behavioral sciences. Otherwise, intention is like a human intention for anything, understand? But this is the intention to use an IT artifact, understand? So
it's appropriate.
So, is there another person? Okay, Emric, you're saying something. Your hand is up.
Oh, I forgot to take it down from no, I didn't have anything else to say. That was it. I was just trying to clarify that. But yeah, makes sense.
Yeah. So then look at Agawal. Okay, let me share my screen again, you know. I have too many things. That's sometimes the difficulty I go through when you are going through this kind of class, you know. I have a lot of information here and there, and then here and there that needs to be shared. Okay. IT identical. Okay, article is a critique of the debate on the IT identity. So this is the Agawal. This was a follow-up paper, you know, to
Agawal and Lucan.
Yeah, yes. I didn't know if you read it in the class, you know. It's a follow-up paper to this, debate. It's a strong debate, you know. So I said that the Agawal and Luke maintains that the following Benzabat's nomological net will result in a micro focus, you know, of IX, you know, and may not move the field forward. So what they are trying to say here is, if we focus only on the IT artifact and everything in its nomological net, then we are going to reduce IT research, you know, into a kind of a mini or micro type of study that doesn't really have that, you know, legitimate, you know, acceptance as a field. We need to, and it's so limiting. Let me put it that way. It is so limiting because of the multidisciplinary nature of IX. You know, business people can publish IX, management people, computer scientists, engineers, understand. In as much as, you know, they are making a contribution, you know, to the use of technology, no matter what the field. That's what Agawal is saying, you know. So we have to transcend the traditional functional boundaries. You know, they must be the IT and the, you know. But you see, the problem is.
But are they saying they're extending the boundaries beyond IT artifacts? So
yes,
you could do papers in IS saying, you know? That have nothing to do with IT.
Yes, going beyond the IT artifact. This is the argument of these guys, understand? There's no need to be, it mustn't be the IT artifact and everything is in nomological net, understand? If there are things that are outside of the IT artifact or its nomological net, they can also be investigated, understand? But you see, the major problem is that most journals, the top journal, MIS Quarterly, you know, they already have structures and mechanisms of evaluating how they, you know, try to validate papers that come in and are accepted. Understand? And this will be one of their criteria. If the IT artifact is not there and they are needed in nomologic. So that's why Benzabat and Zumud will still hold them in high esteem. That paper is still held in high esteem, understand? Because most journal we're going to justify based on whether you have an IT artifact or this in nomologicalness. So if you are writing something, of course, if you're writing to MIS Quarterly, which I've not, written before, you have to really show that it is an IS research you are doing, and not just any other thing. So Agarwal are saying we have to transcend the functional boundaries and adopt a more holistic view, of social systems, more holistic view. So I said I agree with them. Understand? IS must not be reduced to a micro research that investigate phenomenon outside the core properties of the nomologicalness, as Ben Sabat and Zumud, So it depends, everyone. I don't believe in that functional boundary. There is need actually to define boundaries, but it must not be a strict definition. That's my own take. Understand? Yes, we must signal our boundaries so that there's something that defines us, as a field. The medical people have their way. The business people, management people have whatever defines them. The kind of papers that have been published, that have been populated, in their research publications. Ours also should have some identity, understand? But it shouldn't be like a hard and a fast boundary, hard and fast rule that you must stick to this, because there is still, we have to give room for innovation. And that's one of the problems we encounter with theories. People have wonderful ideas, but there is no fitting theory they can use as a lens, for their studies. And if you are submitting a journal article without a theoretical framework, nobody's going to accept it. You see the problem? That's why they say that theory is king. But you might have a wonderful idea. Your idea might even solve the problem on ground. But if you don't have a theory backing it up, you are in trouble. So all these are constraints in research, making life much more difficult for people. So, well, that's the only way to signal this is who we are, this is our identity, and look at the kind of things we publish in our own journals, like IMS Quarterlies and the AIX and the AGs and the rest. This is the kind of thing we do. I agree. We have to have our distinctiveness, understand, in the midst of other fields, understand, but at the same time, we can always collaborate with people in other fields, there has to be kind of exchange between, and that's the way we solve problems. There is no hard and fast rule. So I don't know if there is another thing to be discussed about Benjamin and Zumud. So the IT artifact will always be there. So be mindful of that. Very mindful. Sometimes you will be asked in exams whether this, using Benjamin and Zumud, you think that such a paper will be accepted, or what is wrong? If you are critiquing a paper, sometimes that's one of the critiques we raise when we are critiquing a paper. Usually when I critique a paper, I will read the paper, through the Benzabat and Zumud lens. First of all, I will have to be interested to know, should this kind of paper even be published in the IS journal? What is the IT artifact they are trying to, that informs, whatever research they are conducting, or what is the impact of the usage? I begin to look at the paper, because there is a kind of paper that we give you as an IS scholar. You can, after reading the paper, you can easily conclude that this is not an IS paper. So always have that mindset when you are critiquing a paper. First of all, ask yourself, is this paper? But the easiest way you can decipher, like I usually tell some students, when we are preparing for this exam, whenever you get any paper for qualifying exam, please first look at where the paper is published before you start your critique. It's easier to critique people, understand? Look at where it is published. If it is a conference paper, you have more flexibility to say whatever. If it is, for instance, a paper in IMS Quarterly, tread with caution. You know what that means? Do you understand what I'm trying to say?
That the conference papers aren't as rigorously reviewed?
Eh?
Is that what you're saying, that conference papers aren't as rigorously
No.
reviewed as journal
that's not what I'm trying to say.
They're
I
not
said,
as valid as MIS papers.
yes. So please, yeah, sometimes maybe the way my English may be bad or whatever, please always ask me questions, especially when I try to make a joke or trying to say something. You know, if you don't get anything, just please, you know, always ask me questions, understand? So what I'm trying to say is, if you are giving a conference paper, you have more flexibility to critique because, you know, a conference paper may not have been peer reviewed, understand? Some of them are not even peer reviewed. They have not even gone through the initial review system, you know, which is double blindfolding, understand? They are just initial proposals of an idea, you know, presented to a conference, understand? Which could be accepted or even rejected right away, understand? Or maybe asked to go and improve the paper and then submit to a journal. So if it's a conference paper, you have more flexibility. That's usually the first thing I look at. Before I start critiquing a paper, look at where it is published. If it is a paper published in MIS Quarterly, you know that this is the highest, you know, journal in the field, and they're very thorough. Every publication in the field is thoroughly. So tell me, as a student, what have you to offer? Understand, in terms of critiquing, because this thing has gone through the best of scholars in the field and published. So that's why I said tread with caution. If you want to say you want to critique a paper from MI Scotland, that doesn't mean that we cannot always come up with contrary or contradict whatever information, but you tread with caution, because if you are critiquing, provide enough logic to the contrary. Understand? Provide enough logic why you disagree, you know, with a peer reviewed paper in a topmost journal like MIS Quarterly. Understand? Mostly in every qualifying exam, they will give you conference papers and also give you papers from these top journals. Understand? And when you get papers from these most top journals, it's usually you may read this paper and then use either their own paradigm or use their model to solve a problem from another poorly designed paper, or to, you know, solve a approach or design a problem, you know, solve a problem. So it's usually take this as a paradigm, as a standard, and use it to solve a problem. That's when you get such papers from MIS Quarterly. Understand? I remember during our own time, we were given this paper on hermeneutic framework for literature review. It was published either in the MIS Quarterly. Understand? So we asked to read this paper. We read it during the exam. We are given a problem, and then we are asked to apply the literature review, understand, you know, framework to the problem we are given on the day of exam. So you see how those papers, those public papers published in top journals can, you know, influence the kind of question you are being asked. Usually you are not asked to critique. You're asked to use whatever you learn from this paper and then solve this problem. For conference papers, they will ask you to redesign. Understand? What's the problem? You can critique and then try to come up with a better design for the paper if it's a conference paper. So you have more flexibility. It is always that way. So in every exam, you get top journal articles and then conference papers, you know. Now,
but Clement, I don't think so. We'll have an access online to look up the review or the citation of the paper, the time of the exam, right?
No. You're always giving the papers a week before the exams.
That's what I was wondering too. I saw that there were papers included. So they give them to you a week before and you can study them. Should you study them and study their own citations and try to like learn that topic? Or is it generally you should focus on like the methodology and the claims and the way the paper is structured?
You read the whole paper. You read the whole paper. Understand? If it is a conference paper, you can already begin to anticipate, understand the problems and the kind of questions that will come during the exams. So if it is a conference paper, you critique it. We are going to review. There is a paper written on how to critique a paper. You know, we are going to review that paper in this class. Understand? So you're going to check what kind of research questions, what kind of hypotheses. Understand? Does the research question or the claims flow from the hypothesis? You know, and the hypothesis. So all those stuff, there are, you know, things you are going to look out for in the paper. You know, when you are critiquing it. So most of this poorly designed paper published in conferences, are not always the best of it, you understand? So you can come up with a better design for the paper. So when you read the paper a few days before the exam, you can figure out all the loopholes, understand, and then come up with a better design, so that on the day of exam, if you see such questions, you can be able to, tackle them very well. That's the thing. So you can always know whether it is a conference or a paper published in a top journal, before the exams. That's one good thing about it. And the success of this exam depends so much on your understanding the papers. You have to understand it very well. Possibly sometimes pick up some things in that paper in your memory. I can remember the hermeneutic framework during our own exams. I have to memorize a lot because, it is not an easy thing you can just explain. There are some processes and stages that you need to memorize in order to articulate very well, what you are trying to say. So that's why you need to pay more attention to, the paper.
And the Clement, they always give it a week ahead of the exam, or they always on the qualifying exam, they hand the articles or the paper 1 week before the test day?
Yes.
Or okay, perfect.
A week before the test day, yeah. You read everything. And then if we have this kind of class, that's when this class, is very, very much effective. We can come together and then critique the paper. You take up ideas from various individuals and then look at your own. And then there are some obvious gaps. Everyone can agree that this is a problem in this paper. And then whatever the agreement, and your own personal observation about the paper, you take it into the exam hall, So that's why it's pretty easy to pass these exams, because
I agree with you. Yeah, gonna be easy, very easy, because if you get agreement from different let's say peers, then could make a difference,
Yeah, if we all agree, everyone agrees that this is not an IS paper, or or the evidence they provided is it's not very based on, they don't have a concrete, or they don't have a significant sample to actually draw the conclusion, from the data. Understand? So if everyone agrees on that, it is already an issue. And on the day of exam, you're going to mention the same thing if the question comes, in the way of a critique. So the only problem that you don't know, I can't anticipate the question and don't know how it's, all you can do is to figure out what is the problem with the paper. And then we have that in mind. And when you go into the exam hall, you figure out whatever question. Usually they change questions a lot. Now, I was asking Professor Ryan, we anticipated seeing Kuhn. In the previous years, we've always mentioned the Popper a lot. We are anticipating Kuhn in the last exam. We studied Kuhn, even Laudens, Lakatos, Feyerabend, and the rest. We are expecting that you are going to mention any of these philosophers. He says, no. Sometimes when we look at the way we say these questions, we look at 5 years or 4 years back, and we are trying not to repeat things. Understand? So that means that, okay, maybe the next time you may see another philosopher being mentioned might take some time. You never can predict them. And from my observation, there are some years that are very easier and some years that are very difficult. If you look at the question of spring 2021, the question is so difficult.
Which one was for
2021 spring?
I know, but which class? The 504?
No, all the exam questions.
Oh, all of them? Oh.
Yes. And then when it comes to our own, we took in the fall, fall 2021. The nature of our question is different from the spring 2022. In spring 2022, the questions were not very long, lengthy questions that has 50 marks attached to it. This time around, they break the questions into maybe 10%, 5%, 4%, 3%. And the questions are much more clearer. You can, know when you have answered one and when you are going into the other. In the previous years, you just get 4 or 5 lines of a long, lengthy question, and then you are asked to answer. Understand? Then with one single grading, 50% for the whole, Sometimes you don't even know when you have answered all the, because most of these questions are framed that they have multiple sections in just one question. They make it very clear at this time around. They say they discovered that many students are failing their qualifying exams. I remember one smart guy that left when we were preparing our own, and he changed to another university. He failed the exam the first time, and the second time he wasn't so sure of passing it. So he left honorably to another university in Colorado, you know. So instead of being dismissed, you know, after years of working, and then, you know, it's not always easy, you know. So he has to live honorably, you know.
I see what you're saying. The spring 2021 quantitative research question is huge.
Yes. Okay, you can agree with what I'm saying, you know, what I'm saying. So that is it. You know, it's who the quantity. When we are solving that problem, it took like everyone was, we are not even sure of what, you know, how we are going to approach the design. Understand? It's very, very difficult. But when you are grounded, you know, when you are grounded in all this research, you can always attempt to such questions. Understand?
Was that the qualitative you said or quantitative?
Both, all of them, but especially the quantitative. Understand? Spring 2020. Just compare spring 2021 and then spring 2022. You will understand the difference. Understand? So it's becoming much more easier this time around. So, and I don't know, who knows if in the future it's going to be a bit more easier or going to be complex again. You know, we are not very sure. All we need is to just ground ourselves in most of these principles to understand most of this things very clearly. And now, guys, we are going to look at some of the philosophical paradigms, understand, and some philosophical schools of thought. You may call them school of thoughts, understand, and the major ideas they came up with. You know, the other time I discussed Popper in the group. You know, Popper and his falsifiability theory, trying to distinguish what is scientific and what is unscientific. You know, his major contribution to the history of science is the idea that theorists must be ready to take risks. Understand? Theory, for you to, you know, every theory must be subjected to serious empirical, you know, verification, understand? All in an attempt to refute, not to confirm it. Because observational evidence cannot prove the truth of a scientific theory. That's another place where most scientists, you know, say that Popper destroyed the rationality of science. Why would you say we can't confirm a theory? Understand? Why would you say we can't confirm a theory? So even if a theory comes out with, if a theory makes a prediction and all the prediction comes out as predicted, Popper still refuses to accept that the theory had been confirmed. For him, confirmation is a myth. So all attempts in science, you know, testing in science is just to refute theories and not to confirm them. Because observation is laden, you know, there is this theory we call the ladenness of observation. Because we always look at reality from perspective already defined by some philosophical paradigms. They say that a theory is a lens through which you see the world, understand? But observation is so constrained because you cannot see things the way you usually want to see them in research. You have to look through the lens of a theory. So the theory already defines what you are going to look out for. Understand? And this is one of those problems. Why Popper says an observational evidence cannot be. Because, you know, observation is laden with theory, the theory ladenness of observation. You know, so you are not free to watch whatever. And why we use theory is because a theory will, because reality is so messy, you know, too many things out there, you don't really know what to focus. So the theory gives you that focus on what you're going to look at for. Understand? So Popper rejected the idea of, rather he would say it is corroborated. Oh, the prediction came out as expected. Okay, it is corroborated, but not confirmed. And you know the problem with confirmation is the problem of induction. You know, we have 3 ways of building theories in science. Understand? You know, we have induction. We all know about induction and deduction. In the simplest way, you know, in philosophical logic, we would say, you know, explaining it to a layman, a layman's view is in deduction, you move from a general theory to establish a particular conclusion. There's no problem with that. And everything we do in positivist study, in quantitative study, is all about deduction. That's why the insistence on theory. Understand? So you're either refuting the theory or expanding the theory or rejecting the theory. And you know that every theory has a central claims and sub-claims. And you know that every theory accounts for whatever lies within the scope. It is parsimonious because it gives you precise understanding, precise definition of whatever lies within the boundary of the theory. Very clear explanation. Accounts for all explanation of all the variables that falls within it, like the U-Tout. The U-Tout accounts for all the variables, that defines all the variables that falls within its scope. Understand? So that's, you know, how a theory functions. Every theory has its own scope. So what we do in science is like this deductive approach. So whenever you have a theory already there, know that it's going to be the hypothetical deductive approach that you are going to use, which means on the basis of that theory, you are going to raise some hypothetical statements. Okay, let's say U-Tout have already made its own predictions. And on the grounds of the U-Tout, maybe you want to take this U-Tout theory. You want to apply it to a different context. Understand? You are taking this theory U-Tout to, maybe this theory has already, of course, the U-Tout theory has been tested in various fields. Maybe after researching literature, usually you discover that there's an area that they have not tried the U-Tout. Maybe let's say, let me try to be funny. Say maybe it has not been tested with adoption of cars in among users. I want to know, or maybe a car infotainment system. Maybe you want to know the level. What are the things that motivates people to buy cars equipped with technology? Understand? There have been similar studies. Maybe you discovered in literature that in that area the U-Tout has not been applied, and then you decide to take the U-Tout theory, understand, to apply to this new context. And in this new context now, you now begin to kind of adapt the theory, understand, to the new context. And they came up with new hypothetical statements that now you hypothesize that performance expectancy will, will have a significant effect on the behavioral intention to adopt cars with infotainment systems. How are we very sure that the same U-Tout can work in the field of automobile? We don't know. So, but you are trying to test the theory there, understand? So you come with new hypotheses. So you are hypothesizing that these same constructs will have influence on the intention in this context. So it's all about changing contexts. You are not changing the theory, but you're applying it in different contexts, understand? Where there is an IT artifact usually, and where you want to predict people's intention to adopt, understand? It can be in a school, it can be in a hospital, could be in an industry, manufacturing industry, processing industry, wherever you just want to imply. And so whenever you take the theory to that field, you make new assumptions. You make new hypothetical assumptions that you are now hypothesizing that in this context, because you know that this theory was validated in an organization and with different IT artifacts. And now you are applying it to another organization and then trying to see if these different artifacts, different from the original validated artifacts, can actually have some prediction whether this theory is going to work there.
Can you take a step back? I kind of got lost during this. I follow everything you're saying, but what was your original point?
So my
getting into the U-Tout?
Yeah, my original point, we are talking about Popper, understand his idea about the hypothetical deductive method. And then I try to first of all define them in deduction. Say that deduction is one of the approaches we use in building theories, understand, which has always become the norm in positivist studies. That's why the emphasis on theory. Understand? And using Popper's idea, what you are trying to refute a theory. So the goal, Popper would say, you are trying to refute a theory. When you take, for instance, the youth-out theory, understand, and you want to apply the youth-out to a different organization that where it has not been tested before, or you want to predict a new kind of artifact that maybe because a lot of technological innovation are coming up, and you want to apply the youth-out to see if this new innovation, whether this model will also be applicable, in predicting people's adoption of this new technology. So when you take the youth-out theory, for instance, and apply it to that new context, understand, you will now raise new questions. And new questions are based on this model. Now, so if in the original context where youth-out was validated, it's like maybe they're using a computer, and they said performance expectancy will have a significant effect on behavioral intention to adopt computers. Now, in the new context, you took it maybe, let's say, mobile phones. You now come up with new hypotheses, So all the variables at the left become new hypotheses for you, understand? So you are now saying performance expectancy will have a significant effect on behavioral intention to adopt the new technology you are trying to study, understand? So it is a hypothetical deductive method.
And this is against what Popper was saying, where everything needs to be falsified. You're actually expanding and adapting. Is that what you're saying?
Now the problem with Popper is that even if your prediction comes out to be true, which means maybe the youth-out theory actually predicts people's adoption of the new technology, Popper will say you have not confirmed the theory. Keep on trying until you refute it. And this is an endless struggle into the abyss. So that's what Popper is saying. Popper said you can never confirm, you can never come up and say, oh, youth-out theory actually predicts, has been confirmed in this context. Understand? If the prediction comes out, through, several times within the same context, maybe using different forms of data, collecting different triangulating data, understand, which is usually the way we ensure a kind of validity in our studies. So sometimes we triangulate subjects, or we triangulate data, understand? Even if it comes out to be true, Popper will say it's been corroborated, but you can't say you confirmed the theory. There's nothing like confirmation, understand? And the problem, I said that the problem with confirmation is because of the problem with inductive logic.
And that's the example from the book, like people with Down syndrome have an extra chromosome, but you haven't tested everybody with Down syndrome.
I've not tested everybody. So that's
there's a little bit of induction is necessary, but it's still, the theory's still good enough to say that in all likelihood, everybody with Down syndrome has an extra chromosome.
Exactly. You have not seen like the raven, there could be somewhere in the world where there is a kind of yellow raven, even though all ravens are black. Understand? So, or the Holy Grail that illuminates, forever. Understand? You might find a grail, said, oh, this is the original Holy Grail. And then it keeps on lightening for only a decade and then switches off. So why it is still lightening? You might say, oh, we have the original Holy Grail, until someday when it stops lightening, you discover that this is not the original. So the problem is the problem of induction. And the inductive logic is where we move from a particular instance to establish a general conclusion. And the problem is that even with the problem, not just with Popper and some of the philosophers, is that how can you establish, the veracity, the truthfulness? How can you confirm a theory on the basis of one particular instance? And you generalize to the whole world, generalize to the entire population, understand? And that's what in science they say, collect enough sample, have enough significant sample, so that at least when you generalize in a positivist study, understand, across the population, your generalization will be significant if you have a good sample. It means, and then usually what we do is random sampling. Random sampling is the norm. Understand? There are stratified, and we have stratified the sample where you divide the groups into different, and you can pick up one group you want to study. We have purposive sampling, where you decide on the basis of a convenience, understand, on basis of convenience, understand. to choose a sample. We have theoretical sampling. We are what you usually see in when you are doing a grounded theory. Understand? Theoretical sampling, where the theory detects what kind of data you need to collect next. We have snowball sampling, where you interview one person and the person brings more people. Understand? But random sampling is the best, which means you are giving everyone in the population an opportunity of being chosen. Understand? So, but even if at that, assuming you have 350 people, a significant sample, how are you sure on the basis of that significant? How can you generalize an entire population? Understand? So, Popper, that's the problem with, is a problem of induction that led to the rejection of confirmation by Popper. Understand? Because we are not very sure. Of course, they gave instances in history. What's the Copernican revolution, the Galileo, the man who once said that the world is, I can't remember vividly now. Who remembers, that the world is spherical or circular, was rejected, and then Newtonian laws, some of them we are no longer, it doesn't have, any validity again. Some of them we have been, have been refuted and replaced with, so a lot of theories that used to be the norm then that, helps us in understanding reality have been refuted completely. The whole claim, the whole theory brought down in a matter of decades, replaced by new theories. So even if you say you have, that's why, Straub, in his paper on instrumentation in IS, would say, even if a paper comes out with a kind of, you have a statistical, significant prediction, it doesn't in any way imply causation. It doesn't mean in any way you have unraveled the actual cause, the mechanism behind. Even though it is, the outcome is statistically significant. Understand? That significant doesn't mean that you have explained everything about the phenomenon you are studying. Understand? So that's the problem with induction. The problem with inductive reasoning. So I think we try to capture it. Like, guys, what I'm trying to say is that now we don't need to go deep into most of these things. Understand? You can read at your own leisure, but let's capture the central stories revolving around this, philosophical currents. We understand because these are the most important.
You said induction is moving from a particular instance to establish a general
conclusion. Understand? You studied one organization. Understand? And then you are trying to generalize across the entire population of the organization in the United States. There's a problem with it. But we cannot establish theories without induction. Every theory is based on kind of inductive reasoning, because a theory is meant to account for everything that lies within its scope. Understand? You can't build a theory without that kind of, because the theory predicts, like the youth will now predict that people under these circumstances will adopt this technology. And that's why they are trying to change different contexts, applying youth in different contexts to see if it comes out to be true. And this model has been validated across several fields and contexts, and it still stands with a strong predictive validity. That's why it became a model widely accepted in IX. And the following, Popper's recommendation, understand, the idea of taking risk. This model has been exposed to different forms of risk, meaning trials by different researchers, in different contexts and fields, and it still came out with good, predictive validity. And that's why we call it a model. So you're not going to have theories without induction, because a theory will always predict the future. And that's inductive reasoning. From the context of the study you did in organization, you are predicting that you are predicting the future of the organization. Is that very clear about induction, deduction, Popper, and the rest?
Yeah.
So it seems like Popper would really dislike the IS field because nothing is falsifiable. Everything is context related. There's induction everywhere.
There's induction everywhere. Yeah, prediction is all about some kind of inductive logic, inductive reasoning. Understand? You're trying to predict on the basis of what the data you have. You're trying to predict, the future, of what people are going to do in the future. So that's it. But one thing now with, because apart from a proper and like in positivism, we have two major paradigms in the social science. We have the qualitative and the quantitative. We all know that. And then we have the positivist school of thoughts. And when you look at most of these different schools, their own idea, their major idea is how we understand reality. You know, our approach to understanding reality. How do we understand reality? Understand. The positivist will say that the reality is something that is very objective, you know, something that is beyond, you know, people's thoughts and feelings, not, you know, has nothing to do with subjectivity, or how you feel or how you thought, how you think. The context is not important. What we are looking at is the data out there, understand? And this data has to be numerical. It has to be quantifiable, understand? And we do a lot of experimentations to understand, you know, what is going on, you know. So that's positivist study. When we do quantitative study, we do kind of the positivist paradigm, you know, that objectivity is the underlying statement among the positivists. It doesn't matter who you are, understand? The researcher has no influence, understand? What is more important is your instrumentation. The reliability and the validity of your measures is what we are looking at, understand? So you have nothing, you have no contribution, understand? You are whatever, you are reflexivity or understanding the situation doesn't play much role, you know, in their research. Then we have the qualitative paradigm, you know, which works with the interpretive study, which believes, you know, that maintains that reality is socially constructed. You know, reality is based on people's feeling, their thoughts, the way they see the world, understand? And if you are doing a qualitative and interpretive studies, is usually where you use your major way of data collection is through interviews, focus groups, and the rest, where you question people, and what you collect are not numerical variables, but words. And there is this idea of double hermeneutics. You are studying the people, understand? But at the same time, you are also interpreting the social reality you are trying to understand. You know, so a double way of understanding. And then you are reflexivity, you know, you are the measure. You are the measure in a qualitative study. The researcher is the measure, understand? And to what you do has a lot of influence on your research. To ensure validity and reliability, instead of relying on scales, which we don't have in the qualitative, you rely on audit trails, understand? Member checking. Audit trails means showing everything you did in every detailed part of the way. So if you want to do like a qualitative study, you have to be someone who pays attention to details, because the context is everything in a qualitative studies. The context is everything. The context is noise for the positivists. They are not interested in the context of people there. They are looking at factors. They are looking at numbers. The qualitative is looking at people, people-centered, understanding their thoughts, their feelings, understand their ideologies, you know? So you collect real information, real data, and then analyze it with qualitative data softwares to understand the better, apply different approaches to analyzing data, narrative analysis, you know, hermeneutic analysis, and the rest. So that's for the qualitative approach, understand? So your researcher, you are the measure. So whatever you are doing, keeping the audit trail, the member checking, and all the things that makes for validity, we shall still come to that, but we are still connecting ideas about all these philosophical currents. We also discuss about realism, which believe that the goal of science should be like a texting and building theories. using rational explanation. And one thing about the realist is the idea of mechanisms and structures. Somewhere in Godfrey Smith, they say that the goal of science is to track patterns in the flow of events. Track patterns. What is changing? Understand? So the realists believe that the reality is also objective, which means realism is part of the positivist ideology or approach. Believing in objectivity, believing that science we can create theories through rational explanation. And the realist also believes in the idea of causation. Idea of causation, and every causation involves an explanation that involves a kind of a general law. Remember the problem with causation in science, the empiricists don't want it. For the empiricists, reality is out there, understand, but it doesn't go beyond what we can see. So they have a serious limitation. The data we collect, but still, the empirical school of thought has a lot of contribution, in the history of science and what we do today, because the data we collect from people is actual data, sometimes observable numerical data. So we interacting with actual people, getting actual information from people. If you're doing an interview, understand, So the data you are collecting is based on maybe some observable things. But research goes beyond, reality goes beyond what can be observed. So that's the limitation of the empiricist school, championed by David Hume. And Hume, like Popper, is an inductive skeptic. Because for you to believe, to accept that science can actually explain things, means the idea of causation has to come in. And the empiricists, they try to twist things around, to find a way to come up with their own idea of causation. They come up with this, what is this, this theory that they came up with? The theory that was disproved because of the asymmetry, and what is the name of that? The theory of do any of you remember it?
I remember the asymmetry talk from the book, but it was with the flagpole and the shadow.
Yes. There's a theory. That's that theory. I'm trying to remember the because I don't have I don't want, if I'm trying to scan through the book now, it's gonna take our time. So it's better we post the theory of
the problem of symmetry.
Yeah, but there's a name of that theory. There's a name of that the theory that the empiricists came as a way of they are trying to solve the problem with explanation in science, which involves causation. And maybe before the end of this section, I will remember it. So the problem is the problem of the asymmetry. They say that the explanation can go in whatever direction. A good argument can go in opposite direction, but not explanation.
The covering law, is that what you're looking for?
The covering law, you got it, man.
Yeah, covering law theory.
The covering law theory, exactly. Yeah, the covering law theory. Understand? So that's the empiricist way of trying to solve the problem, but they messed up. Understand? Because of the problem of asymmetry, the asymmetry problem. You can decipher the length of the shadow by the length of the image of the sun, the rays of the sun, and the length of the flagpole, but not the other way around. Understand? You can't use the size of the shadow. Understand? To figure out the length of the flagpole.
It's you can't. The length of the shadow doesn't cause the flagpole to be its particular height.
Yes, a particular height. Yes.
But the height of the flagpole does cause the shadow to be a particular length.
Exactly. So what it means that explanation cannot go in opposite direction. Understand? It is symmetrical. It is one directional. A good argument can go in opposite direction, but not the other way around. Understand? So it was rejected. So came up the unification theory and other theories. But basically, the idea of the realists is that science can be able to explain things. Understand? And every explanation involves a kind of causation. And for us to understand the causation, we have to look at the mechanisms and structures. And that's usually what we do in research. You want to study the mechanisms that are responsible for the observed reality. Understand? Maybe let's say the realist will say A causes B, B causes C. And each time B will always come after A. They will say there is something responsible, you know, there is some mechanism at play why B will always come, you know, after A. So they try to understand, you know, the changes in the pattern of events. There are things that are responsible. And that is exactly what we are doing in prediction, even with the youth-out model. Because there's no way you can predict if you don't understand the mechanisms and the structures that are at play. It's only when you understand, maybe, let me use a simple example. Maybe, let's use, let's use the boiling point of water. You put in water on the gas, and at a point it started boiling. You didn't know at which point when the water started boiling. So people started experimenting and discover once it gets to 100 degrees Celsius, water changes into vapor, begins to boil. No, water changes into vapor when it gets to that 100 degrees Celsius, and it begins to vaporize. But you know actually when it started boiling, understand? And it's when it started boiling, it's not when the vapor actually started happening. So in order to understand the mechanism, so the mechanism they discovered it is, oh, it is actually when it gets to 100, even if it is 97, it doesn't get into vapor, understand? But when it gets to 100, what it becomes a kind of theory, you know, is it in thermodynamics or whatever, understand? The energy, changes of energy from one state to another, understand? So we are trying to understand the mechanisms, and with youth out, you're trying to understand what are things responsible for people's adoption of technology. He said, is it performance expectancy? Performance? Or it's going to enhance their job? Is it effort? For instance, it will be free from effort. So they begin to study, to understand mechanisms that are responsible. So this is a kind of realistic, the idea of the realist. Understand mechanism. So whenever they mention the realism, remember that the realists, they believe in objective reality, you know, about the world, and then that science can study the world and understand the patterns of events and the structures, you know, going on in the world. You know, it is very, very necessary when you are discussing about the realist idea. And one important contribution of the realist idea, school of thought, is the idea of a randomized control trials. Understand? That is the best way of establishing causation. It's experimental. And that's what you do in the pharmaceutical field today with all this COVID virus and the rest. You know, in the health field, that's the most acceptable type of practice, randomized control trial. You test with different population, different groups, understand? Keep on randomizing until you're able to rule out alternative explanation. Understand? You know, so looking at a kind of you know, predictable regularities in the flow of events, there is something responsible for something. Understand? And you want to discover this. It's only when you discover this that you can actually make a prediction. Understand? So the idea of prediction, you know, means that it's a kind of causal, that you have unraveled the causal dimension of what you are trying to study. Understand? Maybe you are conducting an experiment or you're doing a quasi-experiment. Understand? So that's why that experimentation is like the best. But most IS scholars don't use experimentation. Even our model wasn't validated in an experimental way. Understand? You know, the youth out. You know? So like all this randomization, randomized control trials, we don't use because it comes with a lot of cost overhead. Randomizing people, and then they have to give them a little token and whatever. People have to agree to accept to be conditioned to a control, to a treatment group. It is not always easy for an even, you can't even attempt such in a dissertation. Understand? Unless you have a lot of money to pay people and ask them to leave their job, to be in a treatment group. Maybe you administer a drug and then watch over them, you know, for a couple of months and see the effects of that drug on their performance, understand, on their health or whatever. Get maybe 50 diabetic patients and then put them under the drug and then see what's the effect, and keep on texting them at different intervals, understand, So it's not very easy, but that's the norm, but that's the realist idea, realist idea of mechanisms and the structures, understanding the empirical regularities. Another thing about the realist is the idea of they have a retroductive reasoning. They say that even why the future cannot be predicted, the past can be explained by establishing the particular configuration which was in existence. Understand? This is, we call it abductive or retroductive reasoning. Sometimes we may be asked to explain most of these things. During our own time, we were asked to define empiricism, define positivism, define interpretivism, define realism, define scientific realism. So by way of definition, so what you need is a gentleman's idea. You don't need to memorize everything about the realist. But most of the things I'm mentioning there are the things that you need to stick in your mind. The idea of causation, involve explanation that involves, causation. Understand the idea of mechanisms and structures, the idea that science can actually establish, understand, explain, the real world, and to test theories by rational, using a rational criteria. These are important. Then the idea of this retroductive reasoning is also a realist form of logic, even though we may not predict the future, understand accurately, the past can be explained, by establishing particular configuration which was in existence. This is retroductive, going backwards into the past. The idea of replication is also very important. Replication is only trying to an attempt to confirm, the structures and mechanisms, identified in the original research. And that's why we have to pay so much attention to the reliability and the validity of our research, because you cannot establish these mechanisms if you don't have valid measures. Understand? And in simple terms, reliability is all about consistency in the way people understand the research questions or the survey questions. Consistency across various groups and at different time frames. Sometimes you can come up with a research question. Maybe I ask people a particular question, ask a particular question in a survey, and then 3 persons understand it in 3 different ways. So like a kind of ambiguity in understanding that particular question. You think that everybody understands it the different way. Let me use, for instance, we are talking about football. If you talk about football, those in Nigeria will tell you it is soccer. That's the football they know. The ball they play with foot. Understand? But in the US, football is a different type of game, different from soccer. So if you put up a research question and say, have you played football before? And then you expect someone, a Nigerian here in the US, someone who is not yet, who has not really have that kind of maybe understanding about the differences. So you think different people from different countries are answering in a different way. The measure is not reliable. It's not consistent. So, okay, consistency also means that you ask me a question in January, I understood it the same way and answered the same way. You bring the same question again in December, I answered it exactly the same way again. That's why you have a reliable measure. And then when you have a reliable measure, you are sure that you have accuracy in your measurement. That is the validity we are talking about, which has to do with the, accuracy. Validity has to do with accuracy. So poor reliable measures, no validity at all. You have to establish these 2 factors. And they are very important for you to unravel the mechanisms and structures when you are doing a replication. Understand? Because you're looking at different structures and mechanisms that are at play under similar contingent conditions. Similar contingent conditions. Maybe there is this paper on replication. I don't have it handy now. You can search for that paper. There is a kind of different types of replication. It could be theoretical replication. It could be, for a kind of different types of replication out there. Understand?
By the way, I used to support Nigeria team in 2018. They reached, I think, the 6 finals.
Yeah. But the national team is messing up a lot now. The last match they played with Algeria was a mess. We are not impressed. We thought that they are going to win the African Cup of Nations, but they just messed up. Understand? So football can mean different things between an American. So if you put up a research question and think that people understand it a different way, on the same way, So, but when you have a reliable measure, people understand things consistently over time and over, contexts, and the same people from different parts of the world or whatever, whoever is, within their sample population, they all understand the question exactly in the same way. It's not an easy thing to establish, my dearest. Understand? It is not an easy thing. That's why sometimes you have to go through. That's why we usually, in order to ensure that we have reliable measures, what we do is who reminds me before I say it? Who will remind me what we usually do to ensure reliability? Understand? We do a pre-test. We do a pre-test. Understand? Or pilot testing. Some will say pilot testing, some will say use pre-text. They mean the same thing. Pre-text means you use a small population, a small sample, and then put out the question. Understand? And then you analyze the answers, analyze the data and to understand if they really answer the same way. That will give you an insight into whether the measures are really valid, especially when you are adapting to a new context. Maybe you are taking youth out from the original validated context of an organization, want to apply it to a new area of studies. And then what it means that maybe instead of performance expectancy, saying performance expectancy in the use of computers, maybe it is now in the use of mobile phones. You have to ensure that mobile phones means everything to everybody. That's what we call adaptation. And usually to ensure that, you do a pre-test. Put just a little sample population, put out the question and see if they really understood the question in the same way. Understand? Then before you can go into the full-scale study, So they are very important in trying to, when you are identifying structures and mechanisms, under similar contingent condition. That is like a replication for the realist. Understand? But outside the realist, we have the scientific realism. What's the difference between the two? What's the upgrade? That's what
between realism and scientific realism?
Yes.
Oh, go ahead, Emmerich.
Oh, that's what I was going to ask. Which one?
I always get all these jumbled. I'm going to say one of them. No, I'm not going to answer because I don't know the answer correctly.
Okay, so realism actually believes in objectivity about the real world, about the existence of a world that is independent of human thought and feelings. Understand? Reality is something out there. Understand? We can only approach our understanding of reality, understand it in various ways, and usually our approach, our methodologies for understanding reality can be defective. Understand? For instance, our observation is laden with theories. Understand? So the difference lies in the way we observe. But the realism believes in the existence of a real world reality, beyond the human feelings. Scientific realism, understand, goes beyond the real world, to posit that science can actually study the world, give an accurate description, understand, an accurate explanation of reality, both seen and unseen. Understand? Yeah, even though we may not see the atomic structure with the naked eyes, but under microscopic conditions, we can be able to explain accurately the relationship of different atomic structure. Understand? The reaction of the protons and the atoms and the electrons. They are beyond the human explanation. Human eyes can see. If we go by the empiricist school of thought, then we shouldn't be talking about atoms because we can't see them.
Is critical realism? So there's
scientific realism.
There's realism, scientific realism, and there's also critical realism. But that's
we have a critical. We have a lot of. We have sub differentiations of realism. But I want you to just focus on the most important ones that usually is applicable in our field and the kind of questions we see in exams. Understand, because all these different forms of realism are basically the same thing, so a negation of the other, understand, you know? So scientific realism goes, we can give our theories, understand, then we come into the attitude of the scientific realists, you know, with regard to our theories. They contradict, understand, what Popper said in total, understand. We can actually, why Popper says we have to maintain a tentative attitude towards our theories, because they may not hold true in the future, understand. The scientific realist, we have a good degree of you know, confidence in our existing theories, even though we know tomorrow they may be falsified, understand. So this is the whole story of scientific realism. Believe in the objective world and the world that cannot be seen. So science can give an accurate description, and our theory can give an accurate description of reality. And we can maintain a good degree of confidence, no longer tentative attitude towards our, unlike the positivists. The positivists, we are only interested, positivism, logical positivism, trying to understand the world from the perspective of language, the synthetic, you know, and the a priori distinctions of human language, trying to build a kind of a logic of inductive science, you know, inductive logic, trying to build a theory of inductive logic, but they didn't succeed, understand? They didn't succeed in doing that. Mostly they're trying to understand, science should focus on more understanding the logic of language, understand the synthetic and the a priori distinctions, understand? You know, that is for the logical positivist. The idealist will concern with only things that are in the mind, like Hegel and his you know, his Hegelian dialectics, the ideal things that are beyond, you know, that exist only in the human mind, you know. So positivism replaced idealism with the Vienna Circle philosophers who came, you know, Hempel and the rest, you know. So the scientific realist is the ultimate standard of our scientific investigation today. And our theories, you know, are built on scientific realism. And that gives us confidence that we can actually do, you know, all this causation, you know, explanation in science, trying to understand the hidden mechanisms in the flow of events. The empiricists denied explanation, understand, and the causation, because causation is a kind of a metaphysical, you know, it's a metaphysical concept, something that cannot be seen, understand? So the empiricists rejected it in total. They failed with their theory, covering law theory, understand? You know? So the unification theory and the other theories too, we have the scientific realism today, instills that confidence that scientists can go ahead. We can actually, our theories can actually predict the unseen and give an accurate explanation and the description of reality.
Can I try to say a little bit of this in my own words and you tell me if I'm wrong? So realism is that there's a real world outside of human perception.
Yes.
And scientific realism is the fact that science can study and predict this world that's outside of human perception.
And what is outside of it? Yes.
Okay.
Yes. And then Bayesianism, understand? You can study all these things in depth, but even if you don't remember to study them, let most of these ideas stick in your mind. You know, Bayesianism actually came as a result of the problem of induction. Understand? Because of the problem of induction, you know, and the problem of confirmation in science. How are we very sure about the future? We are trying to predict the future on the basis of, you know, what we have, the data we have today. So for some philosophers, oh, induction is a proper, you know, induction is a myth, you know, it's not possible. Understand? How can you establish some degree of certainty? How can you establish the certainty that the data you have today, the theory you have today can predict the future? How are we going to deal with that? You know, this Roman Catholic priest, Bayesian, you know, I don't know whether it is in the medieval period, you know, come up with a solution. And his solution makes a lot of sense. Understand? His solution is that in the light of evidence, we can be able to establish some degree of certainty as regards the occurrence of an event. It has a kind of equation, but in that equation, you always see evidence, hypothesis, and then a combination of these, and what will be the result. You can read deeper. But even if you forget every other thing about Bayesianism, I want you to understand this principle and the central idea. Every other thing there is like, you know, so if you want to go, you may not remember them, but this is what I'm telling you now is I'm not reading from any book. These are the things I'm convinced. Even if you call me tomorrow, the next 10 years, I will still tell you the same thing I know about Bayesian. Understand? So to give an example now, you know I have a red car. Understand? Perhaps you don't know my number, the registration number of my vehicle, but you have seen me several times with a car. You know, maybe we have met somewhere in a grocery shop, we have met somewhere in church or some social event. And then maybe you didn't take so much note of the structure of my car, but you are very sure that maybe something remarkable you know about my car. At least it is red color. And then you come to CGU, you know, come to class in CGU. And they saw the red car. I say, oh, Clement is on campus. Understand? Clement is on campus. So why do you say Clement is on campus? No, I saw this is in Sky. It's a red car. He drives a red car. I said, even though I'm not in reality, I'm not using a red car. And I said, it drives a red car. So there is a probability. That's Bayesian based on, it's built on that probability, you know, that probabilistic, you know, inference. Understand? So there is a higher probability that Clement is on campus in the light of this evidence, the red car. Understand? But it could turn out to be.
Sorry to interrupt, Clement. I have to go. I just wanted to thank you.
Oh, you want to go now?
I have to go. It's 9:30 and I have to take off.
Yeah, might be a good time to call it because I'm losing my attention span after 3 hours almost. 3.5 hours. 7 to 8, 8 to 9, 9. It's not up to 3 hours. Yeah.
2.5. But I have to run. Thank you very much, everybody.
Thank you so much. Maybe we'll continue with Bayesian, you know, next time. At least we're able to do justice to some of the things we want to study. Maybe I will chat you up on WhatsApp. Maybe next time we are going to look at theories because theory is king.
Okay.
Theories,
Okay.
every exam, you see one kind of theory or the other coming into.
Clement, a question for you, buddy.
All right.
Can we have a copy of the slides, the one that you was presenting? Because I haven't received invitation from you regarding the share it folder.
Yeah, because
to my Gmail account.
I shared most of those things in the folder on Google. Have I not added you?
No.
Okay, maybe I will do that.
Yeah, I'm gonna shoot you my email also.
Yeah, send me your
Can I send it here in the text box?
Huh?
Can I send it in the text box? So.
But no, you gotta work. Just send it on WhatsApp.
Yeah, I'll do it.
I already sent it on WhatsApp. Do you want me to resend it?
No, you can highlight it. Just go where you sent it on WhatsApp and then highlight it and just tell me here is it. Understand?
Okay, no problem.
All right, Clement, thank you so much. We'll see you next Monday.
See you next Monday, guys.
Thank you, everybody. Thank you, guys.
All right.
Everybody left. Okay, left. Emira left, and then they didn't even want to signal they are leaving.
All right, we'll see ya.
Free class. Free class and always free.
And Clement, sorry, where we can find the recording of this video?
Maybe I have to download and post. Let me see. Let me stop recording now. You know.
Okay.
I will figure out how this recording works with student accounts. So I have to stop